All right. So, going to be kicking off, doing the kickoff here. So, find the number that makes the ratio equivalent to 48 to 80, as it would be something to 10. So, equivalent fractions, or not fractions, well, equivalent ratios, same thing as equivalent fractions. We're looking for this something that will give us the same value for that comparison, even though the numbers are a little different. So, 48, we're going to have to divide it by something to get down. Well, what we can do is 80 divided by 10, and that'll give us that number. So 80 divided by 10 is 8. So if we take 48 divided by 8, that gives us 6. So 6 to 10 would be that equivalent ratio. So that's the same comparison as 48 is to 80, as 6 is to 10. Now, same thing today with this lesson. Only now we have word problems. So it'll be looking like this. So are these ratios equivalent? So we have to look, will they be the same? So to do that, we're going to try to make them as small as possible and see if they match up. So 16 and 6, we know both of these are even, so I could divide them by 2, and 16 divided by 2 would be 8. 6 divided by 2 would be 3. Hey, that's the same thing as here. So are they equivalent? Yes, they are. On to the next one. So, are these ratios equivalent? 36 to 15 as 12 is to 5. Well, 36 and 15. Not even, so I can't divide them by 2. But they both can be divisible by 3. 3 and 6 is 9, which is divisible by 3, and 1 and 5 is 6, also divisible by 3. So we can divide them both by 3. So 3 goes into 36. Well, 3 goes into 3 once, 6 twice. 3 goes into 15 5 times. Well, hey, look at there. 12 and 5. So are they equivalent? You betcha. Are these equivalent? Well, now we're getting a little harder here. Both of these are going to be numbers that we can reduce. So, 82 and 48. I know they're both even. I know I can divide them by 2. So I'm going to start there. So, 8 divided by 2 is 4. 2 divided by 2 is 1. 48 would go to 2 and 4. Now we're no longer even, so I'm going to stop there. And we're going to see what we can do from there. So we'll go to this other one. So 71 and 42. They're not both even, so they're not going to work out nicely. Now, 71, if you add them together, it'd be 8, which isn't divided by 3, so 3 isn't going to work. 4 won't work because, well, our last two digits won't be divisible by 2. 5's not going to work. Well, didn't work for 2 or 3, so 6 won't work. This one's not going to reduce to be the same. Because if we get bigger, well, even if we did by 2, half of 71 is going to be 35.5, which is not going to be 41. So there's no way to make this one reduce any more to match up with this. So no, they won't be the same. So you got to look at that of, can I make them be the same thing? Can I reduce them down to be the same? If you can't, then it's no. Not going to work. So are these ratios equivalent? 41,000 flutes for every 26,000 clarinets to 82,000 flutes to 52,000 clarinets. So right now, bigger numbers. Sorry, I was off screen there. But we can make those a lot smaller and make them easier to work with. They're all in the thousands. So we could reduce them all by 1,000 to make them a little easier to work with. Now, you may be thinking, wait, 41, if I take it times 2, I get 82. 26 times 2, well, it'd be 12. 1, 4 plus the 1 is 52. Hey, if I double this one, they'd be the same numbers. So yes, they're going to be the same. So if any way that you can make them be the same, either by reducing them down or by making one bigger to match, if they're going to be the same, we put yes, otherwise we put no. And that's it for this lesson. So again, have any questions? Please let me know. Email me, pan me, send me a message on Google Classroom. Any of that works. But please do not sit there and struggle. If you have questions, please ask. So, until next time, we'll talk to you later.